The next reagent is N-bromosuccinimide. This N-bromosuccinimide is a source of a bromine and it will carry out allylic bromination. This reaction is basically a radical reaction where allylic bromination and benzylic bromination will take place. It requires about 5 to 20 mole percent of radical initiator. That initiator may be AIBN, benzoyl peroxide, or UV light at low temperature. As we know that it is an oxidizing agent, the bromination is regioselective. Regioselective means if there are two allylic positions on a substrate, then the bromination will be carried out at more substituted side. That is, the more substituted side will give more stable radical. Now for example, this is a propene. When it is treated with an N-bromosuccinimide in presence of light or radical initiator, it will give you allyl bromide and succinimide. So this reaction involves initial step, the peroxide in presence of light or a heat will gives you a radical by homolysis. This radical which is formed is then react with the bromine molecule to form bromine radical. This bromine radical reacts with the allylic hydrogen. This allylic hydrogen is again removed as a radical by homolysis, and there is a formation of this allylic radical which is a stable one. This allylic radical, propene radical, it will then again react with the bromine molecule and gives allyl bromide. So in this particular reaction, you will observe that there is a generation of Br2 molecule. That bromine molecule is generated from the N-bromosuccinimide, which is a source of bromine molecule. So in this bromine molecule is generated in a low concentration, which is required for allylic bromination. So when we take N-bromosuccinimide, the mechanism of formation of bromine is given here. When N-bromosuccinimide is reacted with this HBr which is formed in the reaction, so HBr is H plus and Br minus. H plus from this HBr, it will react with the hydrogen on this one of the carbonyl, and the Br on the bromosuccinimide will form a Br2 molecule with Br minus from this HBr. So there is a formation of this Br2 and this is succinimide. Now let's see some of the reactions of this N-bromosuccinimide. When toluene is reacted with NBS in presence of light, it will give bromination at the side chain. This is the allylic position, allylic carbon. So there is a formation of benzyl bromide. The another one, this molecule alkene, when treated with NBS in presence of radical initiator, so now there are two allylic positions, this and this one. So as I said previously that the bromine will goes to the carbon which is more substituted. So among these two, this is more substituted, which will form a stable radical, If you compare the radical at this position and at this position, this is primary and this is a secondary radical. So this is the more stable radical, and that's why Br will goes to more substituted allylic position. This is a simple example where this cyclohexene, when treated with NBS, it will give allylic bromination. This is one more. So again there are more than one allylic position with respect to this double bond, and it will goes to more substituted allylic position. So bromination will be at this carbon. This is one more example. Here NBS and this compound which is alkyl benzene. So Br will goes to this allylic position to form benzylic bromide. This is actually the reaction where you have a double bond and two phenyl rings which are in conjugation with this double bond, but there is no any allylic position, allylic carbon, and it will not goes to the benzene carbon. Br will not goes to the benzene carbon. So Br2 which is generated from this NBS is in low concentration. That's why the addition reaction will take place, and from the Br2, Br will add on this double bond to form this three-membered ring. As simple, we will see the addition reaction of alkene with bromine molecule. So there is a formation of three-membered ring, bromonium ion, and this will be attacked by the nucleophile. So in this case the nucleophile will be H2O. It will attack from the opposite side to that of the bromine, and you can see the stereochemistry where the OH is attached to the opposite side to that of the bromine. And this is one more again how we can, or it has been shown that how there is a generation of Br2 molecule from NBS.